let's solve number 1 on your mid-mission study guide. Your question reads, Nevaeh is attending the fair. She can ride the rides for 3 hours for a total of $90. All right, 3 hours for a total of $90. Assuming the price per hour is constant, how much would it cost for 5 hours of rides? Okay, here's our question. How much would it cost for 5 hours of rides? And I've already provided for you a sentence starter with your blank. So it would cost blank dollars for 5 hours of rides. You also have a table here, and it says complete the table to show your work. So the first thing that we're going to do is we're going to go ahead and we're going to take this ratio that we have here. For every 3 hours, it costs $90, right? So we're going to put that information in that we know. 3 hours, $90. 3 hours, $90. Our goal is to get to the cost for 5 hours. Well, I already know that I cannot multiply 3 times a whole number to get to 5. There's no whole number that I can multiply 3 times and get a product of 5. So what I'm going to do is I'm going to go ahead and I'm going to find my unit rate, right? So I'm going to figure out how much for 1 hour. That is my unit rate. So in order to get from 3 to 1, I know that I divide by 3. That's how I am going to get from 3 to 1. So how do I get from 90 to my unknown number? Well, I do the exact same thing. Whatever I do on this side, I also do on this side. So I'm going to take 90 and I'm going to divide it by 3. Well, I know that 9 divided by 3 is 3. So if this is 9 groups of 10, that's going to be 3 groups of 10. 3 groups of 10 is 30. So 90 divided by 3 is 30. Now I know my unit rate, and that's very easy to apply to figuring out 5 hours. So I know that if I want to get from 1 to 5, I'm going to have to multiply by 5. Whatever I do to this side, I've got to do to this side. So I'm going to take my 30 and I'm going to multiply it times 5. Well, I know that 3 times 5 is 15, and this is 3 groups of 10. So 3 groups of 10 times 5 is going to be 15 groups of 15 groups of 10, which is going to give me 150. So what does that mean? That means that the cost, right, I'm in my cost column, is 150. So that's $150 for 5 hours of rides. Number 2. All right, number 2 says 1 quart is equivalent to 64 tablespoons. Okay, that's not something you have to figure out. They're saying that is true. 1 quart is equivalent to 64 tablespoons. So if I took a bucket and I put 1 quart of liquid in it, and I took another bucket and I put 64 tablespoons of liquid in it, they would both have the exact same amount of liquid in them. All right, so, and this is already shown. It says, as shown on the double number line diagram below. So this is already on here, and I can see that it's on here. It's on here, right here. 1 quart, 64 tablespoons. So they weren't lying. There it is. A and B. We're going to start with A. How many quarts are equivalent to 32 tablespoons? Okay. So quarts, tablespoons, tablespoons. And I want to know 32 tablespoons. Well, is 32 tablespoons already on our number line? Yes, it's right here, right? Here it is. But I don't have a value there. So I have to fill in some blanks here on my number line. I'm going to go ahead and fill in those blanks because they might come in handy, right? So I go from 0 to 1/4. That means that I'm going to increase by 1/4 every time that I jump along my number line. So 1/4 plus 1/4 is 1/2. If I add another 1/4, I have 3/4, right? And this could have said, I could have said 2/4, but 2/4 is equivalent to 1/2. We always use our reduced fraction. And then after 3/4, 1/4 more, I've got 1/2. You'll notice if I was to picture this as a model, this would be a model. When we do our fraction models, right, when you were in elementary school and you would be showing fractions using a model. Look, from 0 to 1, it's like a whole, right? It is one whole. It's not like one whole, it is one whole. And it is broken up into 4 parts. So that means that every one of these parts is a quarter, 1/4. And we know here, if I had colored this in, that would show 1/4. If I had colored that in, look, I've got half of it filled in. If I had colored 3 of them in, I've got 3/4. If I had colored this whole thing in, that'd be 1/2. All right, so then I'm jumping again. So now I've still got my 1/2. So now I've got 1/2 and 1/4. I've got 1/2 and 1/2. I've got 1/2 and 3/4. Okay, now my top number line is filled in, and I've got my corresponding value here. So that's going to be easy to go ahead and find my answer. So 32 tablespoons is equal to 1/2 of a quart. So I'm just going to go ahead and answer that. 1/2 quart. All right, that's all you got to do for A. Now take a look at B. How many tablespoons are equivalent to 1 1/4 quarts? Well, handy dandy, I've already filled in my top number line here. Here is 1 1/4, but I don't have a value here. So I need to fill in these values here as well. Now, I go from 0 to 16. That means that as I go down this number line, I am increasing by 16 with every hop. So it's like, remember when we worked on that repeated addition pattern in order to fill in our number lines when we were working with our ratios? Same concept. From here to here, that's plus 16. That means that from here to here is plus 16. And it is. 16 plus 16 does equal 32. So I need to go from here to here. I would add another 16, right? So even if I've got to go ahead and pop this down here and work it out, 6 plus 2 is 8, 3 plus 1 is 4, right? It doesn't matter if you're working it out on the side of your paper, if you're popping that into your calculator, get it done. Do it however you need to do it. Another 16 gets me to 64, and then I'm going to add 16 again. So I'm going to add 16 to my 64. So just work that out. 16 plus 64. 6 plus 4 is 10. Regroup my 1. 6 plus 1 is 7, plus another 1 is 8. So I have 80. And that is my corresponding value, so that I know what is equivalent to 1 1/4 quarts, 80 tablespoons. Is equivalent to 1 1/4 quarts. All right, number 3. Opal is making pancakes by combining 56 ounces of pancake mix with 8 cups of water. All right, maybe we got some Krusteaz mix or something going on. How A says, we've got A, B, and C. A, how many ounces of pancake mix are needed for every cup of water? Oof, for every cup of water. That's asking me for a unit rate. For every, that means for 1, right? And a unit rate is for 1. So it wants my unit rate, and it says to show my work. So there's lots of different ways that I could show my work. I'm going to go ahead and choose to just make a quick table. I just need 2 columns because I need 1 for my mix and I need 1 for my water. And then I'm going to need to put in the ratio that they've given me, and I know that it's 56 ounces of mix for 8 cups of water. But now I want to know for every cup of water. So which number is it that I want to take down to 1? Well, it says for every cup of water, so for 1 cup of water. So the 1 belongs in my column with my water. Now I just have to figure out my missing value here. I know that to get from 8 to 1, I have to divide by 8. Whatever I do over here, I have to do over here. I always start with my number that's part of my ratio and divide that by whatever it is that I'm doing. So I'm going to go ahead and divide 56 by 8. Well, I know that 8 times 7 is 56, therefore 56 divided by 8 is 7. That means that there are 7 ounces of pancake mix needed for every cup of water. It's a ratio of 7 to 1. All right, B says, how many cups of water are needed for every ounce of pancake mix? And you might be thinking to yourself, didn't I just do that? Read it again. How many cups of water? This said how many cups of pancake mix. How many cups of water are needed for every ounce of pancake mix? For every ounce of pancake mix, again, it's asking for a unit rate, right? And it says to show my work. It also says round your answer to the nearest hundredth. So if you're using your calculator for this, I'm going to assume I'm going to go ahead and put 2 and 2 together here, that this means my answer is probably going to have quite a few place values past the decimal point, because it's specifying that I want to round to the nearest hundredth. All right, well, let's go ahead. I'm just going to make another quick table. That's how I'm going to choose to show my work. Again, I've got mix, I've got water, and I'm starting with the same ratio of 56 to 8, but this time it wants to know for every ounce of pancake mix. So now that 1 is going in my column with my mix. How do I get from 56 to 1? I divide by 56. So then how do I get my missing value? I divide by 56. Wow, 8 broken up into 56 equal parts. No wonder it's going to be a decimal point, right? If I took 8 of anything and started cutting those all up equally to make 56 equal parts, those are going to be some pretty small parts. So when you plug that into your calculator, you are going to get a decimal point that looks like, so if I go ahead and I plug in 8 and then I divide that by 56, whoa, look at that decimal. All right, so I've got 0.142857714. Well, guess what? I only care about the first 3 places because I'm rounding to the hundredths, which is where my 4 is. But that means I need to look at the thousandths place because that's going to tell me if I need to round up or down. So I'm going to go ahead and say up 2. That means I'm rounding down, which means my 4 stays the same. When you round down, your digit stays the same. So my answer is going to be 0.14 or 41 hundredths of a cup, right? Because this is in cups. So it's going to be 0.14. That means 14 hundredths of a cup of water is needed for every ounce of pancake mix. All right, last one. Opal needs to make a small batch of pancakes using only 20 ounces of pancake mix, because remember, a single batch mix uses 56. So 20 ounces of pancake mix. How many cups of water will she need? Show your work and or explain your reasoning. All right, so I want to make a batch using 20 ounces of pancake mix. So I know a very specific amount of pancake mix that I need to use. But how do I figure out the corresponding water? Well, guess what? I already have 2 unit rates. I have to be able to identify which one is it that's going to help me solve this problem. If I know how much mix I use for 1 cup of water, is that going to help me get specifically to 20 ounces of mix, right? Because that's what I'm trying to get to. I need to get here. I don't know this. So if I put 7 and 1 here, no. But, if I use my unit rate here of for every cup of mix I use 0.14 cups of water, or for every ounce of mix, 0.14 cups of water, that's going to be so easy, because to get from 1 to 20, I multiply by 20, I multiply by 20 on the other side. Now all I have to do is plug into my calculator 1.42 times 0.14, right, times 20. Oh, what did I do? 0.14 times 20. There we go, 2.8. What does that mean? That means 2.8 cups, or 2 8/10 cups of water to 20 ounces of mix. So I need 2.8 or 2 8/10 cups of water for 20 ounces of mix. All right, number 4. Mary Sue wants to purchase pumpkins. She finds different markets advertising pumpkins for sale. What market has the lowest price per pumpkin? Unit rate. I see the word per. I know I'm finding some unit rates. Show your work and or explain your reasoning. All right, so let's see. We've got East Market, Brister's Market, and Market Fresh. All right. At East Market, I can get 3 pumpkins for $12.30. At Brister's Market, I can get, it's $4.25 per pumpkin. Ooh, I've already got a unit rate, right? That per there, that means I've already got my unit rate. And Market Fresh, 2 pumpkins for $8.30. All right, I'm just going to go ahead and I'm going to go make myself a table for each one of these. Well, actually, you know what? I forgot. I already have my unit rate here. I'm not even going to need that one there. All right, so this is the East Market. I just don't want to forget. And this is the Market Fresh. I've got my cost, right? And I've got the number, just so you know, that thing there you guys call a hashtag means number. Number of pumpkins. And I've got money, and I've got number of pumpkins. Okay. I need to find out my price. Remember we talked about this. Price per pumpkin. It's a lot of P's, right? So what that means is I'm going to take the money and I'm going to divide it by the number of pumpkins. And that's going to equal my unit rate of how much each pumpkin is. So I'm going to go ahead and fill in my information. It is $12.30 for 3 pumpkins at East Market. And it is $8.30 for 2 pumpkins at the Market Fresh. So I'm going to go ahead and find my unit rates. I want to know for 1 pumpkin. I want to know for 1 pumpkin. How do I get from 2 to 1? Divide by 2, which means divide by 2. $8.30 divided by 2. Well, I know that half of $8 is $4. Half of 30 cents is 15 cents. So this unit rate is 1 pumpkin for $4.15, or $4.15 per pumpkin. All right, over here. I got to get from 3 to 1, so I got to divide by 3. Got to go from 3 to 1, so I got to divide by 3. I know that 3 goes into 12 how many times? Well, I think to myself, can I multiply 3 times something to get 12? Yeah, 3 times 4 equals 12. So 12 divided by 3 is 4. 30 cents divided by 3, that's 3 groups of 10, so that's 10. So I've got $4.10 per pumpkin. And I already know that this one is $4.25 per pumpkin. So now I just compare prices. $4.10 each, $4.25 each, $4.15 each. Well, they're all $4, 4, 4, 4, so really I'm comparing the change. 10 cents, 25 cents, 15 cents. Here's my winner chicken dinner, right? So East Market.
You always the last one out.
All right, last one, number 5. Julie can run 300 meters in 25 seconds. Okay, so 300 meters. She takes off. She makes it 300 meters in 25 seconds. Complete the table to represent Julie running at a constant rate. Okay, so we know she's not going fast and then slow and then fast and then slow. She's going at a constant rate. Show your work and or explain your reasoning. They've already filled quite a bit of information in for you. And now you're just going to have to figure out your meters per second. Oh, so I'm figuring out my unit rate. And I'm going to figure out a few ratios here. This is exactly what you guys did on your exit ticket the other day, so this should not seem new. First thing I'm going to do is go ahead and figure out my unit rate. I know that I'm doing meters per second, so I'm going to, for any of these that I want to do, I'm going to take my number of meters and divide it by my number of seconds, and that's going to give me my unit rate of meters per second. So I'm going to take my 25, and I'm going to divide that. Nope, I already messed up. I'm going to take my meters, 300, and I'm going to divide that by my seconds, right? 300 divided by 25, you can pop that in your calculator. You can think about the fact that there's 4 groups of 25 in every group of 100, and this is 3 times as much. Whatever it is that you've got to do to figure that out, it's going to be 12. So that means that she is running 12 meters per second. That is my unit rate. 12 meters per second. All my other ratios that I make here better also be 12 meters per second, and that's one way that I can check my work to make sure that I am correct. All right, I now want to go from 25 seconds to 50 seconds. What do you notice about 50 and 25? I hope that you notice 50 is twice as much as 25. If this was a quarter, I have 25 cents, right? When I have 50 cents, I have 2 quarters. So that means that this is 2 times greater. So if it's 2 times greater, then I need to make this other value also 2 times greater. So I'm going to go from 300 times 2. Well, 3 times 2 is 6, and I'm talking about hundreds, 600. I'm going to check my work and check my meters per second. I'm going to take my meters, divide it by my seconds. When you pop that into your calculator, or think about the fact that there's 2 groups of 50 in every group of 100, and that there's 6 of these, you're going to see that it's a 12 again. So once again, you are at 12 meters per second. Exact same rate, which means that your ratios are equivalent, because all equivalent ratios will have the exact same unit rate. All right, last one. I'm going to figure out my missing value here. Okay, there's a couple different ways that you could do this. You could figure out how many groups of 12 meters it takes to get to 1800 or 1800. But something I'm noticing is this 6 and this 18. I know that 6 times 3, it gives me 18, right? 6, 12, 18. So that means that 3 groups of 600 are going to give me 1,800. That's just from my knowledge of my multiplication facts, and whenever I see numbers that have a bunch of zeros in them, right, I could think about this without those zeros, just think about the 6 and the 18, and then give my answers back its zeros after I'm done. But if 1,800 is 3 times greater than 6, then I need to make the other value here also 3 times greater, because whatever I do to one side, I do to the other. So I'm going to be multiplying 50 times 3. Well, 50 plus 50 is 100 plus another 50, right? 3 groups of a 50. 150. Okay, now let me check again just to make sure that I've still got my same unit rate. That's the way that I'm able to check my work. I'm going to take my meters and I'm going to divide it by my seconds. And I could either work this out, or I can pop it in my calculator just to free up some brain space and not have to go through all of that, because I know I'm going to be using my brain for other things. And you will see that when you put 1,800 into your calculator and divide that by 150, you once again have 12, which means 12 meters per second. Therefore, you have shown me that you have the same rate. Now, it says to show your work and or explain your reasoning. I have shown my work, okay? I've shown that this is 2 times greater, this is 2 times greater, this is 3 times greater, this is 3 times greater. I've shown how I've gotten every one of these unit rates, and I've written my unit rates. This will be fine for showing your work and or explaining your reasoning. If you want to show your work down below here, if you don't want to do it in the boxes, that's fine too. But I got to see how you're getting your answers. You can't just write the 600, just write the 150, and then just write the 12. That's not enough for me to see how you got your answer. So I want to know what your brain was doing. All right, great job.